And we're back online. We're going into the proactively detecting anomalies panel discussion. And with us, we have three industry experts around everything to do with machine learning, knowledge representation, and data science at large. So, what we're going to do is we're going to have a round of self introductions in alphabetical order. And we're going to start with Semih. Semih, could you just give us a little background on who you are and what you've been working on?
Yeah, interestingly, this is the first time in alphabetical order I'm the first. So, yeah, I just realized that. I got surprised. I am a computer scientist and I hold a PhD and I'm working in the University of Southampton as a research fellow right now. And I spend most of my years, more than 20 years on software development and data science related projects, in which some of them includes also AI, predictive maintenance, and those kind of forecasting things. And yeah, that's me.
I'm Travis Hansen, I'm a product manager for Alitrack. I have nearly 2 decades of experience, both in construction out in the field, working in telecommunications and wireless technologies. And in the last 2+ years, I've been a product manager for our internal and now external software platform called Alitrack, where we collect digital asset info on assets across the globe.
Thank you. Vijay?
Hi, I'm Vijay Boppana. I'm a data scientist with Melvin Group. I hold a PhD from Wright State University. So I had like a couple of masters in electrical, masters in computer engineering, and then PhD in electrical. And then for the last few years, I have been working for a series of startups. Currently, I'm working as a data scientist for Melvin Group. Yeah, that's it.
Well, one of the key tenets that we want to address in this panel discussion is how to proactively detect anomalies and what is the value of doing so. So one of the things that we were talking about prior to getting into this live panel discussion is the irregular or illogical behavior of humans. You could predict what machines do because they have a defined set of functions, but people themselves are volatile and unpredictable. Um, do we want to talk a little bit about the business use cases that you have seen around how to monitor and regulate some of these irregular behaviors? I think Travis, with the presentation you gave in the previous session, you can start us off and give us a little bit of context with what you've done.
Yeah, so we collect data out in the field. That's what our platform does. It's all human-powered data collection, but with human behavior, it's completely unpredictable compared to a machine. With a machine, you know that the dampener might be going out because you'll see an odd vibration, or maybe something needs to be replaced. But with inspections, it's really based on behavior, which is unpredictable. And using AI, I think what's great about the power of AI is it's unbiased for one. As long as it's trained properly, but it's unbiased and it's producing flags on this behavior. So working with Melvin Group, we're able to reduce our false flags in human behavior and produce results that create anomalies that may trigger for rework or some training or quality control. There's plenty of reasons that we might have an anomaly flagged, but it really replaced the full-time person. I mean, as far as a business going, you'd be inundated to go through 500 million telemetry data points and try to sort for anomalies on your own, where this algorithm runs in 20 to 30 minutes and we get a whole new data set of algorithms that are being popped up. So it really gives us return on investment and enhances the quality and workflow of the product.
Thank you, Travis. Semih, Vijay, anything that you've seen across your industry experience around anomaly detection?
So since I work with Alitrack, that was the last project that we worked together, Melvin Group and Alitrack. So I work closely with Travis on detecting the anomalous behavior of the inspectors, actually. So that anomalous behavior might be intentional or unintentional. Sometimes, the understanding the data and pre-processing the data and running finding out an appropriate model to find out the anomaly. Those were the tasks that I performed, actually. And as I mentioned before, like, the the interaction, the continuous improvement, and then the interaction with the subject matter expert here, in this case, like Travis Hansen. That was very helpful in detecting the anomalies. So, as you mentioned earlier at the beginning of the session, if you would like to like find out the anomalies in a machinery, like for example, if there's going to be something is going to be happen, or if something is wrong with the machines, and if it's behaving anomalous, there will be like preset of functions that we can use to determine if it's anomalous or not. But here in our case, this is the first time like finding out whether the human behavior is anomalous or not, kind of in a specific niche field. Like we work together to find out if it's really anomalous behavior or not. Yeah, kind of. So that was one of the use case, and it can be used in predictive maintenance, and the anomaly detection can be used for that, and for fraud detection, anomaly detection can be used for that as well. Yeah. And then it has like a bunch of other use cases. Anything behaves unusual, like anything, we can put the anomaly detection system or the pipeline into action, and then we can find it out. We can come up with like many things. Like for example, take the computer or the machine, the personal computer that we use. If certain parts are not behaving properly, maybe because of some bugs, or like hardware bugs. I mean, how we call it, hardware trojans or software trojans. Like some parts might unusually get utilize so much power. Anything unusual, like we can use the anomaly detection to find something, like in security, or in many cases, yeah, in industries, and yeah.
So, yeah, excellent points. There are internal, external circumstances that may affect the normal behavior of a system or a particular function in that system, and being able to detect that has these downstream benefits. Um, I, prior to us starting the panel discussion, we were discussing some very specific examples. Semih, you mentioned working on the proactive maintenance and monitoring of certain.
Yeah, yeah. Let me summarize that. Um, I mean, what we do when we buy a new machine or a new product or a new car, in the first year we just depend on the warranty. If there is anything, we just take it to the mechanic and they get fix it. And when I buy a machine to produce something, I'm kind of safe to use it for during its lifetime. And those type of definitions are already defined in manuals. When you buy it, there might be some agreements and some servicing contracts and so on. But there are also some cases in the industry which may require some continuous servicing need for an unreplaceable machine. We worked with an institution before, and the machines were unreplaceable because of something. So I may not be allowed to go into detail. So if you cannot change the machine, you need to plan for the maintenance, because at any point that machine is unpredictable. So at any point in time, there may be a breakdown, and one breakdown costs a lot of money. And if you can predict before the breakdown happens, then you save a lot of money. And if you can predict how many different parts you will need to replace in the next year, also you can save a lot of money to keep your stocks at a very optimum level. So that was the thing I dealt with, and it was a very interesting case, and especially on predicting the needed stock for the next year was a very good result. But if you go into data collection side, you can have many different sensors, and by just collecting info from sensors, that's another story which can lead up a predictive maintenance as well. For example, you can just check for the vibration on the machine continuously, and based on the vibration patterns, you can predict if there will be a requirement for an unpredictable service maintenance. That was the thing. I mean, we can discuss further after this introduction on different sides of it.
Excellent. Well, thank you very much for contextualizing that example. Travis, you were mentioning the proactive inspection of utility poles. What are some of the downstream consequences if that maintenance is not performed at an adequate time frame, or
Sure.
if there's no maintenance and a negative consequence happens?
Yeah, no, that's a great point. Well, by leveraging AI in the platform, data integrity is key, and all of this data that we're capturing, and we want to make sure it's as clean as possible, because what ends up happening is it gets passed off to the customers. We just our own internal crews. And when we're passing off to the customers, it could be the estimated remaining strength on a wooden structure, or there could be hazards identified. And there's nothing more critical than getting this data set to the customers in the most pristine condition that could be in, because the data that we're turning in might trigger a utility pole replacement or something else that's been identified. Maybe there's a hot ground wire, like some condition that's unsafe for the general public. These poles, they're going to fall over. So there's a lot of maintenance that is being performed from the data that's being turned in. And so within that, having the data integrity as clean as possible is definitely key, because there's weather events and certain other events where you can't withstand a power outage. The power grid is already getting strained, especially with the advent of EVs and network. And so we're already limited. And I think data cleansing, getting the data properly in, is the key to continuity within. And these things are not just that, just also reducing liability and risk against the customers and ourselves.
Thank you, Travis. And Vijay, you were talking about in very high level terms, the impact of monitoring energy grid and energy consumption to ensure that there's no overload on existing infrastructure. Was that a...
That's actually, I brought a small topic of an example use case of how we can find anomalies in a computer, in a personal computer or laptop or in a phone, how we can, this is a discussion about how we can extend the anomaly detection into any field, such as, for example, if there is a hardware trojan in our system, in our PC, in a chip, and then if it's behaving unusually, because unusually, even if the machine is in sleep mode, or low performance mode, or even if the machine is not actually performing any functions, but in the background, some parts of chips, or some parts of processors, certain processes might do something because of hardware trojans, or because of some other software bugs too, or vulnerabilities or something. So we can find those using the anomalous power consumption by that specific part, that specific chip, or that's one use case of anomaly detection. Or We can also like use, instead of coining the word anomaly, instead of using the word anomaly detection, we can say outlier detection, and then we can say like since the energy consumption is getting increased because of the newly constructed houses, factories, or the excessive use because of the EVs. We can say, and then excessive, people are started using more electrical component, electrical equipment and stuff. So we can use outlier detection to find when exactly what time of the day, or exactly what time of what day of a week, or what a week of a year the consumption will be more, and we can predict, and then we can predict, and then we can provide, we can try to you know, you know, provide more power. We can handle the power. What do you call, like the power delivery industry can like manage very well, like how to at what time they have to deliver, like the power, at what amount, kind of. And coming to what Semih said, that was interesting too. Like when I heard that discussion, I came up with like a long chain of it's a long chain of it creates a long chain of products actually. So detecting the for example, if there are wear and tears in a machinery part in an industry, or in a factory, or in a car or anything, if the sensors, but based on the readings from the sensors, and if we can predict and then find out the trends, and then when, if we can predict like when exactly we need to replace certain parts of car, or if we need to maintain, if we couldn't be able to replace certain parts, as I mentioned that if we couldn't be able to replace it, we should be able to like perform some maintenance. So we can create an orchestration of like a big process. Like it's going to automatically say that particular product is going to be wear out in like a month or in 2 months, and then it's going to automatically send a message to the the, the the producer of that. For example, if the car manufacturer, or like the car owner, or if the machinery owner of the machinery expects, or like prefers to get it from a certain factory or something, a certain manufacturer of the part, then it can automatically trigger or send a message to the to the product producer of that part, that it that the that part need that user with that part, that user might need that part, or that user of factory might need that part in a month, or in 2 months, or in a year, or in a specific time, and then
I
they can organize the production. They will know, like, the actual producer of the product
I
of this.
think
Yeah,
I think you bring up a really good point, that we are really looking at things through a procedural perspective. It's not just what's happening now. It's based on the history of how a machine, or an organization, or a set of actors perform in a bigger system, that allows us to know, is this a positive behavior? Is this a negative behavior? And if we're getting some signals or some indications that something bad is going to happen, what what can we do proactively to prevent that negative consequence from happening and mitigate that risk? So ultimately, that's the whole point of anomaly detection. What are the negative consequences that come forward from not being proactive in preventing them? Um, I know we were talking a little bit about how adverse weather conditions may also impact agricultural domain, or even the same example that Travis was bringing up, the development and monitoring of polls, right? So you mentioned that that's something that you also actively track, Travis.
So we're just tracking our our maintenance on the poles, and maintenance that needs to be done, but not necessarily with AI at that point. But the systems certainly exist, right? There's certainly systems that are monitoring the power grid, and predicting anomalies, or maybe even power shutoffs due to weather events. I know here in Southern California, the Santa Ana winds are going, and I'm sure that there are systems in place that are using some AI to detect weather patterns and what routes would need to be shut off when, to determine an outage, especially with the fire risk and the vegetation risk with trees blowing into power lines or clashing together and starting fire. Sorry, I think there's a lot of power in AI and leveraging all of that data and whatever sensors they may have on the network, analyzing that and predicting these large catastrophes.
Out of curiosity, what have been some of the business impacts or observations or even remarks that you've gotten from implementing these solutions in practice?
Well, I know that just having clean data is the biggest thing. It just reduces the risk and the retrips, and we find we might find something with our own internal teams inspecting data where like a ground wire or a guy wire on a pole that's holding it up might become energized and hot, and just making sure that data is coming in, making sure people are where they say they're supposed to be, and reducing the liability for the customer, and our users. So it's a bit tough, but I think overall we can prove where we said we were. We have the anomaly detection to prove if something doesn't seem normal, or maybe the pattern that the inspector going isn't as efficient as it could be, and then just validating that data and making sure it's as clean as possible. Really, all comes together to make sure that the customer can perform maintenance on the network as needed.
What were there any like insights or outcomes as a result of delivering this first solid solution internally?
Yeah, I mean, I think what it did is it triggered a lot of awareness with anybody using it, that there's a worker running in the background 24 hours a day that's very cheap, that's triggering anomalies. It really creates accountability with actions and just performance as well. And I think everything that we're going to get from this is going to be increasing revenue accuracy and just efficiencies within the team, reducing liability and risk, as always, because it's just a massive factor when you're performing work like this.
Semih, any insights or observations from implementing that solution you mentioned earlier, preventing irreplaceable machines from breaking down? Oh, you're on mute.
Sorry, I mean, there are kids around me. My children can go in, so this way I mute myself. Sorry. Yeah, there are two types of predictive analytics on these kind of scenarios, and it depends on the time constraints, and it depends on how much data you need to consume, and it depends on how fast you should respond back, and if it should be like, meaning that it should be sometimes a real-time feedback may be required for an alert, an emergency alert, or something for a long-term prediction. So there are too many unknowns when you start on such a project. So in some prediction tasks, we may require some real-time output, and those may be dependent on some sensor input. And when you need to deal with such data, you have to work with a very high load of data as a stream. And stream analytics has its own algorithmic part. But when you go into a long-term prediction, you can work with a bunch of data, which is not time critical, but time consuming. So as far as I understood, Travis is working with some loads of data, which can take some minutes or hours to process. So in my case, those two scenarios had their two different use cases. When you listen a sensor, you need to act quick. when you listen a sensor from a machine, and you're like, just like, for example, predicting an earthquake. So the longest time prediction you can make is not more than 30 minutes, right? With the current the current technologies. So if you're trying to predict something which is time critical, then you need to process it in a way that is different than processing it as a batch. So in my case, what we did, it was not a time critical process. We got a bunch of service records for the machine, including the spare parts and the inventories. So the fluctuation of the inventories were the main input. What happened? So the machines were interestingly more than 50 years old, and for some reason they couldn't buy a new one, and that is, and they have to continue using those as well. So that was the critical point. But the only thing as a requirement was they want to know at least like 1 month before that machine will break down, and they make a complete servicing on it, which will prevent the a sudden stop in the middle of nowhere, in the middle of the night, sudden stop which requires much more emergent attention and which costs a lot of money. What we did was, together with that input, we created a full year of prediction and monthly inventory prediction for the customer, and which was a really good output. But I'm telling, so it's not an easy thing to do, but there are too many algorithms and too many methods that you may use, and there are also some companies and software specialized for those type of tasks. But what we do, we mostly use our human side to feel the data first. That's how they call it. Then by feeling the data, which means understanding what can be predicted, you apply some algorithms and you get the results. So I don't know. I hope that clarifies the at least a higher level of understanding for the technical side of it.
No, that's perfect. And I think Vijay was making an excellent point about that before, that when he got involved, the first thing that he needed to do was socialize the data and understand the derivatives of actions and behaviors that can be taken. Um, Anything that you can say, Vijay, on that, on feeling the data and socializing it?
Oh, I felt very happy hearing from Semih saying feeling the data, because I always say that word actually. Yeah. Yeah. So yeah, understanding the data or feeling the data, like as I mentioned earlier, that was the key, key part of, or like a key aspect of, or which played a major role in successful deployment of the project. Not only in our project, as I mentioned earlier, like it's going to be the key part in any project or any product development which involves dealing with the data, which primarily involves dealing with the data, or like, so in our use case, uh, um, so initial understanding was, when I understood. I mean, at the first instance, when I understood the data, I couldn't be able to completely get. I mean, some use cases throw me off. Like, so some use cases, or like some data was not making any sense. And then when I started understanding the data more by interacting with the subject matter expert, like here Travis is the subject matter expert actually in the field of inspections. So I was understanding every day I was understanding the data better and better, and then which which made I mean which I think which helped us to complete the project quickly. So instead of spending more time on actually not understanding the data and then spending more time on like finding out like picking up right algorithm or like right hyperparameters or something, instead of that, understanding the data, I mean, reduce the design cost. I mean, development cost, design cost, whatever we call development cost, but I mean, development cost in terms of human hours, or reduced a lot actually. If we can understand the data quickly, that's it. Then the rest will be straightforward. We have all the services required from different, all the services or the tools required, algorithms required. We have everything. If we understand the data properly, I would say more than half the problems solved over there. Yeah, yeah, yeah. That's what I can say actually. Yeah, understanding the data. Yeah.
I think one of the major tenets as well in discussing these areas of real-time detection or long-term data harmonization for longer batching of detecting anomalies is that just being able to deliver even a chunk of this is a great form of validating that this technology works, and it doesn't have to be incredibly fancy or you know one thing I hear all the time is IoT is a $2 trillion industry, but most of it has gone to waste because nobody knows how to wrangle all the different sensors into a unified model that represents the real world. Um, what has been your experience in implementing these solutions, as well as the downstream requests for expanding this into other directions or other use cases?
Is the question for me, Joe?
How open dialogue.
Well, I can just say that, just kind of playing off that a little bit is understanding how AI can be, an impact for your business. Once you do have a product solution that's working and you found that there's great value in it, it certainly opens eyes to others around you on different use cases. And I think that's kind of the takeaway that we got from, working with Vijay and his team is once you produce something and it's producing actionable results, and things that make sense, you start looking at other various business proposals where AI might make sense. So whether it IoT, we're not really doing any of that right now, but just an example of taking all of your contracts and proposals and putting them in a place and training a model on all your documentation and having your own internal Google search engine that's contained, and just finding efficiencies of how can you search through contracts and summarize and find differences, or there's just a lot of doors that are opened once you understand the process and you have a good idea of where it can save time. I think for us that was something that happened.
Yeah, I can add some technical side of those IoT style projects. When I start thinking about IoT, I usually start by asking two major challenges on IoT. One is the energy challenge. So IoT requires a lot of sensors, might be deployed in a distributed manner. And together with that energy challenge, it requires a lot of communication need. So that goes together. So in that category. The second thing is the IoT devices produce different type of data, and I have been working with different. I mean, we were not calling them IoT 20 years ago. We were calling them telemetry devices, and in those days, every single telemetry device had its own standards in binary format, and we were reading those. And nowadays, there are predefined standards of IoT devices producing some JSON style data, some XML type, some binary type. I mean, it may differ based on the producer. But the major challenge is to have a semantification of the data itself. And in some projects in IoT related anomaly detection, it might be crucial to have a semantic framework first, to have many different IoT devices talking the same language, which means, for example, we can use ontologies to have a semantic definition of what that IoT device produces. And there are some technologies which you can collect that data as a graph, which may help you to analyze it as a graph, which means in a connected, in a linked manner, which may lead to some advanced analysis. That's how I look at the issue when I think about IoT. But I am usually on the side of semantifying it and analyzing it.
Thank you, Semih. Vijay, what have been some of the techniques or some of the underlying architectural patterns that you use to bring meaning and sense and sort of organize, in human terms, the machine learning models that you employ to detect these anomalies?
You mean the technologies that I use to build the ML pipeline, kind of? Or...
Yeah, just a high level on how you bring sense between the business side and the technical representation, the technical data bits.
Oh, okay. So we used AWS platform, and then we used services such as like SageMaker. In stuff like initially, this was this is what we did. Like in stuff like trying to like create a complete MLOps pipeline in a AWS environment. What we did was like initially we were like doing rigorous testing. I did the rigorous testing in my local PC, Azure. So I downloaded all the data from the Electrax system, then did the performed all the analysis locally. Just focused instead of focusing mainly on the infrastructure. First, I focused on understanding the data by performing the EDA and like trying to find out what kind of algorithm will be suitable for this kind of a data, because every data behaves differently. The distribution will be different, and so that's what I did. At the beginning, using my personal, the work machine, and then after that, I moved to AWS and I used the SageMaker. I kind of came up with a couple of other ideas of implementing the same solution, but we stuck to we decided to go with SageMaker. But I had other ideas of using lambdas and lambda functions to create the solution. Yeah, at first, the first implementation, we saw the cost of SageMaker are very high, and then sometimes the cost of daily operations are high. So we made it to a scheduled job run, because it doesn't have to be real time. We can make it real time, but we decided to go like a batch processing, do all the processing, pre-processing, training, and then everything on like a batch scale. So we decided to go with the SageMaker and SageMaker jobs to schedule it to run all the complete steps in once a week. So the SageMaker notebook has everything, all the extraction from the RDS database, and then doing the cleaning, pre-processing, model training. Everything was done inside using the SageMaker notebook. And we used as a kind of service secrets manager to pull the credentials, and store the credentials, and pull the credentials whenever we need to access the data from the RDS database. So we did that actually, and we included that part as a small security feature. And That's mostly the technical side of the implementation of the project. But the main crux of the project is, as I mentioned earlier, understanding the data. Like it was an iterative process. It was like a very we did it like very fast. I mean, me and Travis, we used to kind of used to work like around the clock, kind of. Yeah. So we were like exploring the data, and then if it's making sense or not, and then even after the completing the cleaning process and pre-processing, even like not only after like finding out the anomalies, even after like completing the cleaning and pre-processing, also like we used to have like interactions and like is this data like looking good, is this data making sense kind of to feed into the anomaly detection model. And then after it was like a very rigorous process. And then we reduced the I mean we re- and then the one more challenge we faced was, since we were running the batch processing, so we didn't want to do the pre-processing on like, because we're gonna get, we have to like we have to, but if it's weekly we have to like perform pre-processing on hundreds of thousands of records. But if we have to do it for a month, it's going to be millions, months and months of data. It's going to be billions of rows of data. So what we did was, like, every time when we pre-processed the data, we stored the pre-processed data in a separate DB. And then after that, weekly we were like pulling the new fresh data, and then we were cleaning, and then we were like augmenting, or like what do you call it, augment or add the data to pre-processed or clean data to the existing DB to save the time of running the pre-processing. Because even though the data was like huge, the pre-processing was taking a longer time. And to reduce the cost, kind of, even though it's not that it's not going to cost too much, but we try to reduce the cost by just pre-processing only the week, the past 1 week of data only. That's one thing. And running this jobs, because when we run when we automate the process of running the SageMaker notebook, we have to like invoke a different instance, which should be more powerful, and then which is memory optimized, kind of. So that was one of the steps that we took. I mean, we followed to make sure when we trigger. I mean, when it is invoked, the notebook job is supposed to like invoke a larger instance. I mean, compute instance which has like more memory and stuff.
It,
Yeah.
it makes perfect sense that you guys would take a agile product development approach to developing this platform. I mean, you had an existing hypothesis, but even in the collection of this data, it wasn't clear how to fit it into a model, what shape or quality or health it had, and how to harmonize that into a full scale model, or what are the constraints in the real world scenario of how much is this thing going to cost to run, and what are the trade offs in doing it closer to real time or longer term. So that makes perfect sense. I guess what I was more curious on, and feel free to weigh in this, Semih and Vijay, what were in your after computing this solution, what are some of the core tenets of developing an architecture that make sure that this is a robust detection system? I know a lot of it has to do initially with like the iterative development of business use case, data, production.
Yeah, that's what I wanted to touch as well. But what if an anomaly is not an anomaly? What if you detect something wrong? What if you are more wrong than right? So the quality of these systems may be may get worse. I mean, it is not a static process, and it cannot be statically defined from the beginning. And if, as Vijay said, I mean, there is a high load of pre-processing tasks in most of the projects, and those pre-processing may be required in the middle of the project or after the project as well. So we usually define, for example, for pre-processing, some pipelines for continuous pre-processing of data for the next incoming data. But how do we calculate the quality? That's the biggest challenge of most of the AI projects which are going in the industry. I mean, in the academia, we use benchmarks. We use benchmarking on testing the model quality. But in the industry, we can come across with some data which is quite new and we don't know anything about it. And how do we process it? If you hire a human being to just click if it's wrong or right, it might be more costly than hiring one person to just watch the screen and make an alert in an anomaly, for example. So that is a challenge. There are many different ways of handling that. For example, we had projects which we call them classification tasks, which requires pre-labeled input. But we can also have some algorithms which we call them unsupervised, like clustering of some data points, which can also lead to some results in some projects. And there are also some totally statistical and mathematical equation results which can lead us like there is an anomaly because in average it's not like that. We can all use these, but the biggest challenge is always at the end. What is the quality? If you convince the manager on the quality, you get the job. So that's how we end up on failing again and again. Maybe I don't know, but if the customer convinces on the quality, then that AI becomes a very powerful product at the end. Yeah, I don't know if it makes sense, but I wanted to point it out.
You brought up a great point, Semih. Actually, we had that thing too, because the problem was unsupervised problem, anomaly detection, and then there were like no direct like metrics to perform the actual performance of the model behavior. So we were like manually validating by testing it. But there is a way of using supervised learning, kind of along with there is a way of using supervised learning to find out the like kind of an error, but it's not a like an appropriate direct way or like complete way of like saying.
Unsupervised learning has its own metrics. Just to be precise, for example, in clustering, for example, you can calculate a metric which shows you some type of a distribution, for example. I don't exactly remember the names of those metrics, but those unsupervised approaches never provides you something meaningful to have a final result. You have to comment on it. You have to have an understanding on the data. And it's really challenging. I mean, I worked with unsupervised method to convince a customer before, and it's a real issue.
Oh, you're absolutely right, Semih. Actually, I totally agree with you. I think we had this discussion a couple of times with me, Travis, and then internally in the company, because in our, internally in the company, like they were asking what are the metrics to evaluate the performance of the model. But me and Travis, we were like Travis was like manually validating the results, manually verifying it. But still, we are I think we need to, in the next phase or so, that we need to come up with a way of finding out the metrics, as you said. You're right, actually. We just manually validated the model's performance, actually.
They will not get convinced. I can say. I don't know who is the customer here. Travis is the customer.
Yeah.
Yes.
It's quite tricky. This is why scientists exist. So we try to prove it.
That is an interesting idea that the system itself is part of a dynamic evolution of functions, and sometimes you can't trust the sensors, sometimes you can't trust the existing data. I mean, who's to say you don't implement plastic poles or poles made out of marble or other kinds of composite materials, and the historical data is rendered no longer relevant. So, what are some of these techniques that are used to proactively take into account these variations or changes in behavior or structure in the system?
Look, in hardware-related systems, there are anomaly detection software which may take up and down the sensor itself. So if there is a sensor which started working like crazy, as soon as it is marked, then it is phased out. And most of the hardware related software providers which are working on hardware related issues comes up with such solutions. But as far as I know, usually they don't use really high level or artificial intelligence type of solutions. But they are mostly deterministic rules which prevent those hardware to create further noise within the system.
Alongside that, in Travis's case, as it stands for now, you're keeping humans in the loop to ensure that even if you have a high level of confidence that this is working to your needs and specifications, for whatever reason, if anything seems odd or you get false positives or other kinds of permutations of unexpected behavior, what are your strategies for engaging with the solution as it stands with all its limitations?
Sure. I mean, currently the human loop is purely manual. There's no intervention, but I know in future iterations we're talking about developing a learning ML ops pipeline with the human in the middle. But it's more complicated than that, especially in our industry. I mean, we train a model based on a certain type of inspection, but there's lots of inspection types and there's different processes. So certainly an expansion will be training different model sets based on different inspection styles. So we understand each scope of work in that aspect, where right now it's fairly generalized. But we will certainly have to evolve. And I know I've been working with Milvian Group and understanding what that takes. But I mean, you could drill a utility pole with a device that tests the resistance across the bit, as we do in one of our inspection types, or you could have another type of inspection where somebody has a big manual drill and they're digging around the pole and using this drill. Each one is faster than the other, and they have different patterns and behavior. So certainly the models will have to evolve, and then putting a human in the loop where somebody's giving me a thumbs up and thumbs down based on detection, and then also adding other parameters into the model. I mean, we start with a fairly simple data set just to reduce the amount of confusion and not throw too much at it, and just kind of hone in on what we're doing initially. But there's a lot of other telemetry data points that we're currently not looking at, and those will come into play depending on inspection types and points, and it will improve the process over time.
Yeah, I would like to add what Travis said. We are expecting to do even more phases of work. Actually, at the end of first phase of the work, we detected even more features. Actually, we would like to implement those features, and then as Travis said, we might have to explore, understand the other sets of data from the tools which will be used for the inspections. And we might have to come up with, as Semih said, we might have to come up with the proper metrics to evaluate kind of. So yeah, there's some more work to be done actually. Yeah.
Well, that's a good
It's
thing
not
for you guys, huh?
Yeah.
All right. Well, we're drawing near the end of the panel discussion. So, are there any last-minute words of advice or just key insights that you'd like to share around the development of robust detection systems?
I would say simply understanding the data is the key for the success of any project, and perfection takes time. So every time we think humans, we think, oh yeah, we know everything, we achieved, oh yeah, we completed this, but there is always more to be done. As I always mention, 90% of the 90% of the, I mean, efficiency can be achieved in 10% of the time. I mean, but the rest 10% might take like 90% of the effort. Might, kind of. So I would say like perfection takes more effort actually. Yeah.
Yeah, I would just say, when you're looking at any of these solutions, it's only good if you're utilizing them. So make sure whatever solution that you're looking for, that it's with purpose. It provides something that your customers or your teams can use. Otherwise, it's just an expense that won't ever be really utilized. And I think there's a lot of software out there, or different add-ons and features that we probably pay for that don't really do anything for us. So, just focusing on and honing in on what you're good at. Like what we've done with our telemetry data and producing anomalies, it makes sense, and it's easy to use.
Any last words, Semih?
Yeah. The data science does not work with luck. So if you look for a lucky result, you usually fail. And when you try to detect anomalies, and if you cannot evaluate your quality at the end scientifically, it will be very hard for the managers and for the maintainers in the future to trust the system. So unfortunately, I'm sorry for the industrial people, but I'm partially industrial. So without using real data science and the quality metrics of real data science, those type of projects mostly goes into a failure. So that's my last words, and it was a very nice discussion. And this is the first time I met with Vijay and Travis, and I know you from our previous calls. So thanks for inviting me, and thanks for this fruitful discussion.
Thanks, Semih.
Thank you, Semih. Thank you, Travis. Thank you, Vijay. Yeah, well, we're going to close out the panel, and all recordings will be available in approximately 2 hours. So, yeah, enjoy the rest of the conference.
Yeah, thank you.
Yeah.
Bye-bye.